Hello, welcome back to BLENDERSUSHI Live Noding. In this episode, we're gonna continue with the color grid explorations. We're gonna use the setup from previously, and I can just load it from my JSON, or you can grab it from the Gits. I'll show you real quick. So basically, if you just go to this video of mine, SV color grid template, just right click here and then copy link, and I can just hide this. And with Blender and Sverchok installed, you can just go to the node tree and then SV import and just copy paste and then get it from the gist. And you should have the color grid almost ready. You need to switch to cycles, delete the default cube, file, save as. This is grid. I'll call it grid array for now. We're gonna try to create some kind of gradient. By the way, this setup requires some materials, cycles materials, like we set up in the previous live noding. So I create the node tree, and then in cycles material, you can keep it diffuse, or you can use emissions and just plug in the attribute node, Sverchok color, because we are using vertex coloring for this to work. If you check vertex paint, it should already kind of work. This is from previous live noding, and you have this all kind of randomness happening. We don't need vector noise, scalar. This is kind of the basic setup. Basically, you have the grids already being generated from here, and then you have vertex color nodes to do the coloring, and we're gonna play with this. So this is the random RGB. You can actually just draw on top of this if you want. Yeah, something like this. You know, it will always reset itself because Sverchok is kind of resetting the color. Okay, we are ready. In the next live noding, I'm probably not gonna show you this. I'm just gonna load the template. I'm gonna save the template as well. Color grid file, save as grid array. Okay, let's play with this. Let's have the index being displayed. Polygon vertices. Okay, something like this will do. Okay, where should we start? So we have 10 by 10 square grid, and we have 100, like 100 pixels. We can generate more, but we're gonna play around with this. For this one, we're gonna try to generate some kind of gradients, but more proper gradients. The gradient that's kind of flowing in that directions, from left to right or from right to left. Even more, you can maybe we're gonna generate kind of a gradient that goes from bottom up or from bottom top. Okay, gradient we can generate using color range. So for now, we're gonna kind of think of these numbers. Just imagine all these numbers is actually like a single line. Imagine if this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the next one kind of like this bar that I highlight with red, kind of a single sequence of number. Okay, and imagine the second number. If the first sequence of number, we kind of generating like a color maybe from white to black or from black to white, it's become like a gradient, right? If we kind of repeating the same thing over and over again, we're gonna have like a gradient that go from left to right. So that's kind of the first idea, the first sequence that we're gonna do. So let's do that. Let's work with a single color for now. Instead of random number, we're gonna use range of number. Range float will do, because we're gonna need like a range of number from 0 to 1. The value is going from 0 to 1, and the count is how many like a number, how many slice of numbers you want between 0 and 1. So in this case it's 10, because we have like 10 in here. So if I just plug that in, I should have, see, this number from black goes to all the way to white. Okay, that's sort of work, and we actually here only have a 10 number. Whoops, it's just Blender just crashes because I didn't restart before I do this. This always happen. Maybe some kind of bugs with Mac OS and the QuickTime recording, and I don't know. I'm just gonna restart because it's okay, because I always save anyway. I'm gonna restart this real quick. File, open grid array, and okay, we're back. So check with the stethoscope. It could be the numbering. We only have 10 here, right? 10 values plug into this, something that's require kind of 100 values in order for this to work. And okay, let's try kind of repeating the number. Perhaps that's gonna work. List repeater, and try repeating it like 10 times. So we have like 100 numbers, and we can also unwrap it. I think if I just plug this into this guy, we'll see that it's not actually working. Yeah, this is just like in the previous live noding. I tried to use the list repeater, and this apparently doesn't work. I wonder why. Let's have a look at text viewer. Text viewer. Hopefully this is something that's easy to fix. Let's check our data. So currently we have this kind of data. 10 objects, 10, 10, 10, 10. So 10 times 10. What we need is kind of like a simpler kind of data. We need to probably, if I unwrap it, now it's looking like this. Still not what we want. Not what we want. Level. So level 0, 10, unwrap. So that's not what we want, but this is kind of almost correct. Maybe I need to list join it somehow. Let's join 10 data mix wrap. Sometimes just try and error kind of work. I have a feeling I might also need to slice the data somewhat. I'll try just plugging this guy in. This is a pretty silly. Actually, just now it works. This actually works. Let's have a look at the data now. So 0, 1, 2, 3, 4, 5, 10, 100 data value. Okay, this is good. So this is the original data. It's just 10 value. Remember, this is a single floating value, and then I just plug it into XYZ vector, and it's become, this is gonna be the RGB. And this is the original data. You see the list of data. So we are using list repeater and list join, and then we end up with this new data. This is basically what we need. 100 data being repeated 10 times, and then yep, this is perfect. This is exactly what we need. So I'm pretty lucky there, just using list repeater and list join, because of the this is actually because of the Sverchok data structure. What we are doing here is really like imagine if you are creating this using code, and you have to use kind of loop, and the loop normally kind of you set up the loop so it generates one data from value from 0 to 1 like that, and then it's gonna do repeat it, and then make another lines 10 times, and so all this data together is become this gradient from 0 to 1. Okay, so yep, good. That seems to be working, but we have to be probably more clever than this. What if we want to reverse the data from 1 to 0, like from white to black? Can we actually do that? In this case, we can really just start from 1 and then stop at 0, and that will basically work. If you want it like a red color, this actually gonna work. Oh, wait a minute. If that's 0, okay, from red to totally black, nothing. So this is if we are mixing the red color gradients with green, we get this yellow to green, and then we mix that to blue, and we get this unusual white to cyan color. Yeah, you can play around with this actually. In fact, if you're kind of curious, what if we are doing it like this, like start stop from 0 to 1. Okay, that's kind of nice color. If we have just the red and green, of course, red going from 1 to 0, and then green going from 0 to 1, and we mix it together and we get this color. Color gradient, nice color gradient. We can at some point kind of doing the same thing in a different way. Maybe I should actually show you real quick using vector lerp. Vector lerp is actually very interesting. If we use vector lerp evaluate here, don't use the lerp, use the evaluate, and we have two vector. Imagine this is a red color, and imagine this is a kind of a blue color, and we want to create a gradations between the two. Check out using viewer draw, and let's have a look. Where's the dots? Maybe we can hide our thingy for a bit. Outliner, hide our grid, and hide our index viewer. We have these dots, and we have something. We have the vector. Okay, it's kind of transitioning from 100 to 001. Imagine this guy is representing color red and blue. We kind of interpolating between the two. If we use a range float, we're gonna get something maybe for the vector between 0 and 1, we have like 10 count. So we have 10 sampling of data in between red and blue. Okay, this is what vector lerp does. Actually, vector evaluate, because it's kind of generating the points. With vector lerp, you get a different kind of situation. Vector lerp is actually really good for animations. If you have like two position and you want to move objects from starting positions to the end positions, you can use vector lerp. And you have like, even if you have like a bunch of points, maybe 100 or 1000, whatever number of points moving from position A to position B, you can use vector lerp. Vector evaluate will actually generate the points, kind of like tracing between the 2 points. Very interesting kind of very interesting note, I guess. If we use this vector lerp and plug it into our grid, what's gonna happen is we have some kind of gradient from red to blue. How many we have? We actually have 10 data, and this, because this is Sverchok, with the 10 data, again, you can use a list repeater, I believe. And okay, we have to do the same thing with list join, and then we have the gradient. This is like almost like magic, I guess. Look at this. This is 10 data, right? And we are kind of repeated 10 times, and this is the color red kind of being lerp, being evaluate. So we have some kind of gradient, color gradient. It's pretty unusual, maybe not exactly obvious at first that you can do this, but yeah, this is possible. And then obviously at the end we have like 100 vector data here, kind of a two-color lerping. We can increase the number of interpolation lerp, and yeah, we have some kind of interestingness happening there. That's because of we have like a fixed grid 10 by 10, and then the data we can just pass in like a random number of data. This one is like a repeat of data from one value to another value, from pink to blue, for example. In this case, we can use different color. I guess this is quite interesting, the fractal lerp. Yeah, don't worry about that again now. I'm just gonna delete it, or maybe I'm gonna keep it. And for you, this is using lerp, vector draw. We don't need this. We don't need this. Okay, back to where we were before. This is a color from red to green. Not so obvious here because this data is kind of this is the red value, this is the green value. It is actually more abstract here compared to the bottom one. If you're using another open source tool like processing has this kind of way to use lerp, linear interpolations between two color that you can simply apply to generate a similar kind of gradient color. Okay, so that's pretty clear. And this is the gradient that goes from left to right or right to left. If we want gradient that goes from bottom top or top to bottom, and since this is like a grid, kind of like a 10 times loop, because it's grid 10 by 10, we can kind of devise that as well. Imagine if we have so we have like a sequence of numbers, right? I'll turn on the index, and we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our sequence, okay? 0 and goes to the next one. If I draw it using grease pencil, it should be like this, 0 to 9, and then it's kind of a jump, and then goes to the next one, and then do it again. It's kind of like a loop. This is computation, like a computational thinking once again. So knowing those kind of looping pattern, if we want gradient that goes from black at the bottom all the way to white at the top. This means that we can kind of slice, make like some kind of repeat and slice. So for the first one, maybe you want all black, and then the next one slightly more increasing in value, and the next one. You can use a repeat and slicing, I guess. So start from range float once again. This is okay. This is one example. I'm gonna frame it. This is gonna be for top bottom or bottom top gradient. So this is the default. Actually, if I plug this into all three, we have from white to black. From white to black. What if we repeat the white 10 times and then repeat the next color 10 times, many times? How do we do that? Let's have a think. We can use slicing, list slice, and then kind of repeat it. List repeat. If I'm not wrong, this is gonna work. So I'm slicing the value here and then kind of repeating the slice. Well, actually not list slice, maybe list split. Okay, that's more correct. List split. So originally we have 10 data, and we split the data into 10 data parts, and for each part we can kind of repeat it. So that's will be clearer if we use this number. See, I split. Originally we have 10 data like this, just a single list. Now I'm splitting the data, and then it's becoming 10 split of data, and then now I repeat it 10 times for each. See, if I repeat it twice for each one, we have 1 1, and the next value. So this way we can actually repeat it 10 times here, and then maybe unwrap it. Maybe I need another join somewhere, but let me try this real quick. Yeah, I believe I need another join, list join. This is just slightly more complicated, but still pretty simple. Okay, yeah, that's the theory is kind of working. So we have 10 data, we split it, and then for each split we repeat it 10 times. So originally, imagine if we have like data that 1 2 1 2 3, and then we split the data and then repeat it. So we have like 0 0 0 0, 1 1 1 1, 2 2 2 2, 3 3 3 3. Okay, that's the basic. I'm gonna delete the grease pencil. By doing it this way, and for the grid of data, array of data, we have the gradient that goes from the bottom to the top. If we want to the opposite, we can just change the value here, 0 to 1, and then you can just assign it just like the other one. Cool. So if we can blend the two, actually if we use the data that's gradient from left to right and right to left, and then all those, we can combine it together, and we should get something. We should get an interesting combinations. Just mix all these three data. Yeah, so that's one of the theory. It's still pretty basic. If you want like a diagonal kind of color, like from one corner to another corner, that's gonna be slightly more interesting. I still don't know how, but I'll have a think on that. Maybe we need to rotate it or something. But I'll show you one more thing that's really interesting, is that instead of thinking the data in an array list of fashion that we kind of repeating, so this is like I'm gonna join this. So we have 3 ways to generate like a gradient. Gonna disconnect this. We have actually one more that I could think of. So instead of using the kind of like a list grid pattern, we can use one more thing, which is from the points itself. From the original points, we already have some kind of grid, right? The grid generates these 10 by 10s polygons, and it has, each one of them has locations, and location itself, of course, if you observe the locations and look at the X and the Y, it's kind of like a growing pattern. It's already a pattern that repeating 0 to 10, 0 to 10, and we can actually just use that as our color, which is it's pretty interesting, pretty amazing. If we just plug in the vector, we're gonna get a color, but it won't be like a gradient. It's gonna be it's almost like gradient. It's 0 to 1, 0 to 1 very quickly. You can actually remap it or maybe normalize it. I don't know. Vector math and normalize. Maybe going to give it a kind of gradient. Okay, 0 and then weird color gradient. If we are not doing that, instead if we are kind of normalizing it ourselves, we can get hopefully like a gradient. 0 to maybe 0 to 1, 0 to 10 becomes 0 to 1, clamping on and off. I don't know. You see, we already have like a gradient from 0 to 1. Sverchok map range actually doesn't go the opposite way. 0 to 10, you cannot just lerp it become 0 to 10 become 1 to 0. It's not right. In order to reverse it, I guess you can use math and kind of minus the value, maybe minus and absolute. I don't know, I have to think about this. 1 to 8. Okay, this is doing 1 minus the value, so it's reverse. Okay, that's working. Nice. So yeah, here we have control with the value as well. We can kind of adjust the value and make it like super contrasty. So instead of gradient, we have like a single line. This is kind of, it's pretty weird, right? But it's working. And then you can also use the opposite. Instead of X, we can use the Y, and we have this vertical kind of gradient from 0 to 10. See, this is another way you can generate gradient. Okay. Yeah, I guess that's pretty much it for this live noding. It's just a simple gradient and how you can think of color grid and how value is actually changing based on row and column, or if you're using the vector position. It's much easier, and this is exactly how shader kind of procedural texture works. Whatever like a vector noise or vector fractal, in order to generate a whole kind of this abstract pattern, it's using the position like of points in space, and it does it in really fast kind of way. So yeah, that's I guess that's pretty much it, except that actually I have one more idea. Actually, this is, I just came out with it. Using the same idea, this list split repeater and join. Maybe we can use the randomness. I will use this list repeater and list join once again. with a random number. Imagine random number, and if we just generate like a 10 of them, floating value from 0 to 1, we have this random, see, random number at the bottom. I just plug in this float into color and it seems to work. We don't need to use a vector in. Here we can repeat, of course, list repeater and list join. List join. This should work. And make it 10 times. Yeah, this is working just like the gradient thing, except that we really have a random number here, and this is, I found this thing is pretty useful. This is like repeating the same random number 10 times, 10 random numbers repeated 10 times, kind of like looping it 10 times. It's very interesting, and if you understand this really well, it's gonna be easier to do what you want to do next one. Let's say you want to, for each list being repeated, you want to kind of list shift it, if you can. I don't know if you can, but I'm pretty sure Sverchok actually can do that. You see here again, list shift is shifting the number, shifting the random number, and even crazier here with a list shifting, you can use range integer. I guess you can do that, or maybe you cannot. Maybe list shift is not being factorized, or maybe I need to use list join right here. If this works, I will be like really surprised. Sometimes Sverchok surprise me. Yeah, I think list shift doesn't do that, but it's I reckon it should, but maybe we have to do it differently. Yeah, okay, anyway, I'll leave it right there. It's just another play with this random number, and you can do that. You know, it's pretty interesting. Would be nice if we can just shift it randomly for each line. Maybe we can, I don't know. Anyway, that's pretty much it for this live noding. A lot of concepts to understand here, but hopefully this is useful. Let me know what you think. Any feedback, suggestion, question, I try to answer it. Thanks again for tuning in, and I'll see you in the next video. Thank you.